Good afternoon, ladies and gentlemen. I would like to say thank you for coming in my presentation. It's great to see you all. Let me introduce myself and my partner. My name is Putu Angga Suta Dharmawan and my partner is Igusti Ayu Agung Diatri Indra Dewi. We are from Sticky, Indonesia. In this opportunity, I would like to present double exponential smoothing Brown method for sales forecasting system with a linear and non-stationary data trend. So we do this research at Ude Paramastor. Ude Paramastor is trading company engaged in the sale of retail goods which sell various types of daily necessities at retail. Goods that are sold are finished goods purchased from distributor that can be stored in warehouses or can be displayed directly on the shelves in the store so they can be resold and selected directly by customer. The procurement of merchandise is the owner will physically calculate the existing goods or through the system he already has to find out the amount of stock of goods that is running low. Next, the problem is slow-moving goods can settle in warehouses and stores due to excessive purchase and vice versa. There will be a shortage of goods that move faster. The idea is the store needs a system that is able to predict the amount of inventory that must be purchased by shop owner to reduce the risk of deposition of goods, especially goods that have linear and non-stationary data trends. The method we use is double exponential smoothing Brown. Proposed by Brown is a forecasting method used when data show a linear trend and non-stationary data. The trend question is an increase or decrease in data that occur in certain periods or a long-term decline or increase. The non-stationary data in question is a periodic series of data that show no non-stationary properties if the underlying generation process that does not have a constant average and has various value. This is a double exponential smoothing Brown equation. The process is first the equation for single exponential smoothing. Second, the equation for double exponential smoothing. The next process is determination A variable. Next, determination B variable, and last is a forecasting equation. In many forecasting situations, accuracy is seen as the criterion for refusing to choose a forecasting method. In many cases, the word precision refers to the virtue of ultimately indicating how far the forecasting model is capable of reproducing known data. We use MAPE or mean absolute percentage error method. The first step is we must calculate the percentage error for every forecasting data. Next step, we calculate the mean absolute percentage error by averaging of all percentage error. The data used in this study are mostly sales data for products with a linear and non-stationary trend based on unit row testing with augmented Dickey-Fuller method in a few applications. The data obtained were 5 types of products with sale periods starting from January 2018 until December 2019. Those data have linear and non-stationary data trends which are suitable for this forecasting method. The system overview. The forecast period to be calculated is entered first. Next, sales data in previous period and alpha values will be searched in the database. Next, double exponential smoothing Brown method is used to calculate forecasting for the next period. And the last, the forecast result will be stored back in the database. The training forecasting will be done from the range of alpha of 0.1 to 0.9 to determine which value will be used in actual forecasting calculation. The actual alpha value for forecasting system is obtained from the smallest MAPE value. In this example, calculation the value to be used is 0.20. The calculation example can be see on my slide. Next is a calculation of accuracy of forecasting age period using PE or percentage error and APE, absolute percentage error. That can be see on left side of my slide. And next, the calculation of the overall forecasting accuracy using method of MAPE or mean absolute percentage error, that can be seen on the right side of my slide. The next is forecasting detail peg or the implementing the method to the system. This display used to display the detailed result of the forecasting process with various weight. This display also includes a description of the result suggested by the system. The intent result is the result with the smallest error value in the forecast calculation process. On this page, the user, in this case the owner, can use forecasting data as a basis for consideration in making decision in determining the number of items to be provided based on the total estimate sales in the coming period. And the next is a forecasting analysis page. Forecasting analysis page is a display that show the comparison between sale and forecasting result for the sale period, which is used basic data in determining forecasting. The comparison is used to determine the value of forecast calculation error. Comparisons are displayed in a graphical form, can be seen in the top of the page, and comparison table form in the bottom. Based on the result, it can be seen that average MAPE value is 19.11%. The result indicates that trend analysis to determine the suitability of trend data used in forecasting as an influence on forecasting result. The previous research did not state about it. Best alpha value for each item product can be used in the next period for forecasting calculation. The smallest MAPE value is 9.84% for Sampurna Email 16S, while the largest MAPE value is 32.42% for Ultimate Chocolate. Those results indicate that the higher the fluctuation in the sale value, the higher the resulting MAPE value. So the conclusion is self-forecasting system with the double exponential smoothing Brown method has been successfully implemented by displaying the result in the form of forecasting data with the lowest error value or error in the next period with data that has a linear tendency on and non-stationary data. The level of accuracy of the forecasting system with the double exponential smoothing Brown method result in the average rate of 19.11%, which are calculated using the mean absolute percentage error method. So, thank you very much for your great attention, ladies and gentlemen. If you have any question, I will be happy to open up the discussion. Thank you.